Here's the answer for the homework, page 87 orals. We'll start with number 1. We're asked to figure out the slope of the line that's in the diagram. There's a diagonal line drawn, and on that line are an infinite number of points, but only some of the points touch the exact corners of the little grid squares, and those points are the ones that it's easy to figure out their coordinates for. So let's locate 2 points on this line that we know for sure touch the corners of the grid squares. One of them appears to be here at the point 1, 0. Another point appears to be here at the point 3, 3. Let's measure between these dots to find the slope. The definition of slope is the rise between 2 dots divided by the horizontal run between 2 dots. Start at the dot that's furthest to the left and figure out how to travel to the dot that is to the right. We rise 3 units, you can count the squares, 1, 2, 3, and then run horizontally 2 units. Again, count the squares. When you move 1 square, say 1. When you move the next square, say 2. This is rise of 3 over run of 2, or 3 halves. Problem number 3, let's use the same technique. Find dots on the line that actually touch exactly in the corner of the grid squares. There looks to be many you can choose from. For example, right here and right here. From the dot furthest to the left, to travel to the dot that's to the right, you would go down 1 unit, that's -1, and then to the right 1 unit, a +1. Down 1 over right 1. This reduces to -1. Number 7, we're given an equation and asked to find the slope. This equation is in a particular format where the variable y is alone on the left side, and on the right side there is an x term and there is a constant term. When an equation is in this format, the slope is the coefficient of x. So for problem 7, the slope is -3. Number 9 is also in that format where the letter y is alone, and then there is an x term and a constant term, although the constant term is just a 0. The slope is the coefficient of the x term, so our slope is 2. Number 11 is not yet in the form that's easy to find the slope because the letter y is not alone. Let's divide everything by 2. 4x divided by 2 is 2x, and -12 divided by 2 is -6. Now we have what's called slope-intercept form, and the number in front of x is the slope. And so m is equal to 2. Okay, number 13. This is actually already in slope-intercept form. It's just the letter y is not on the left side. But we can use the symmetric property to fix that. On the other side of the equals is 6 minus x. Let's write the minus x first and then the +6. That's okay because of the commutative property. Now we have slope-intercept form. The number that's in front of x is the slope. And so the slope is -1. Number 15, this is not in slope-intercept form. The letter y is not alone. Let's transform it. Subtract 4x from both sides. -6y equals -4x. Then divide by -6. -4x divided by -6 looks like this. But that reduces to 2/3 x. This is slope-intercept form. It's just that the constant on the end is a 0. So what is the number in front of x? It's 2/3. Now page 89, the written. We're given 2 ordered pairs. These create points or dots when drawn on a grid. We're asked to plot the points and then draw a line. So let's start with this one, 2, 3. This is the x-coordinate, this is the y-coordinate. So from the origin, go to 2 on the x-axis, and then travel upwards 3 units. Here is 2, 3. Now let's find 4, 5. This is its x-coordinate, this is its y-coordinate. From the origin, go to 4 on the x-axis, and then travel straight upwards to a height of 5. Now we're going to draw a line through these dots. There's another part to number 1, and that is determine the slope from the graph. We practiced this earlier. When you know 2 dots on a graph and you want to find the slope of the line, you find the rise and the run. So from the dot on the left, you rise 2 units. I know it's 2 units because I'm looking at these marks over here on the y-axis. The first dot lines up with this mark. That second dot lines up with this mark. It's 2 units between there. Okay, then running horizontally, it's 2 units. I know that because I'm using the marks on the x-axis. From here, moving to the right to this mark is 2 units. So our slope is rise of 2 over a run of 2, which reduces to 1. We're asked to check this using the slope formula. Let's do that. The slope formula is m represents the word slope, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. These 4 variables are the numbers from our original ordered pairs. This was our first ordered pair. This one was our second ordered pair. The little numbers in the bottom corners called subscripts are telling you which ordered pair to look at. So y2 is referring to the 5. y1 is referring to the 3. x2 is referring to the 4. And x1 refers to the number 2. It's the x-coordinate of the first ordered pair. y1 is the y-coordinate of the first ordered pair. Let's apply our formula. y2 is 5. y1 is 3. x2 is 4. x1 is 2. This makes 2 over 2, which reduces to 1. We got the same answer from the formula as we did by counting rise and run on our graph. Next, number 3. Let's plot the points and draw a line through them. First we have 1, negative 2. That's right to the 1 on the x-axis and then down to negative 2 on the y-axis. The other dot is at 4, 6. That's right to 4 on the x-axis and then straight upwards to a height of 6 on the y-axis. And draw a line through those dots. Now we're going to find the slope of that line from its graph. Start at the dot that's furthest to the left and travel towards the dot that's further to the right. Count the rise and the run. 1, 2, 3, 4, 5, 6, 7, 8 units up. The rise is 8. Now let's travel to the right. 1, 2, 3. The run is 3. So the slope is rise of 8 over a run of 3, 8/3. Now we're asked to check that answer using the formula. So the slope formula is m equals y2 minus y1 divided by x2 minus x1. Let's identify what the 4 variables are in our original ordered pairs. This is the first ordered pair, so it's the x1 and the y1. This is the second ordered pair, it's the x2 and the y2. Now let's fill in our numbers. y2 is 6. y1 is negative 2. x2 is 4. x1 is 1. Let's evaluate this. 6 minus negative 2 is 8, and 4 minus 1 is 3. We get the same answer. Next is number 5. Let's plot the points and draw a line through them. 5 comma negative 1 is right to 5 on the x-axis and down 1 unit to negative 1 on the y-axis. Negative 5 comma negative 1 is left to the negative 5 on the x-axis and down 1 unit to negative 1 on the y-axis. When you draw a line through the dots, you notice it's a horizontal line. Now let's find the slope of that horizontal line. From the dot on the left to travel to the dot on the right, you don't rise any units. They're at the same level on the paper. So the rise is 0. You do run sideways 10 units. So the slope is a rise of 0 over a run of 10 units. And this reduces to 0. Let's check that answer with the slope formula. The formula is m equals y2 minus y1 divided by x2 minus x1. These 4 variables are the numbers from the ordered pairs. This is x1 and y1. This is x2 and y2. So y2 is negative 1. y1 is also negative 1. x2 is negative 5. And x1 is 5. Let's evaluate this. Negative 1 subtract negative 1 makes 0 because any number subtract itself is 0. And negative 5 subtract a 5 is negative 10. This reduces to 0. We got the same answer. Now number 13. We're asked to draw a line through the point negative 1 comma 2, and we want the slope of our line to be 1. So let's find the point negative 1 comma 2. Go to negative 1 on the x-axis, and then go up to positive 2 on the y-axis. There is negative 1 comma 2. Let's draw a line through that so that the slope of our line is 1. If the slope is 1, then the rise was 1 and the run was 1. 1 over 1 simplifies to just a 1. So from this dot, rise 1 unit and run to the right 1 unit. There's another dot on the line. And you draw a line through the dots. Number 15, same idea. Put a dot at 2 comma 3. So 2 on the x-axis, and then up 3 units, there's 2 comma 3. Now let's think of this slope as rise over run to find another dot on our line. Do you see that negative there? That means that vertically, we're going to go down 1 unit instead of rising 1 unit. So from our dot, count down 1 spot, and then run 4 spots. 1, 2, 3, 4. Here is another dot on the line. And we draw a line through those 2 dots. Whenever the slope is a negative number, associate the negative sign with the numerator of the fraction. Think of this as being negative 1 over positive 4. Number 19, we're given a table of values and asked, are these points on a straight line? If so, give the slope. For these points to be on a straight line, if you were to graph them, they have to line up. There has to be a consistent rate of change between the numbers. Let's find the rate of change between all these numbers. From the very first ordered pair, 0, 5, to travel to the second ordered pair, 1, 7, how has x and y changed? The x has increased by 1 unit, and the y value has increased by 2 units. The rate of change, also called slope, has a rise of 2 and a run of 1. Let's see what happens between the second ordered pair and the third ordered pair. From a 1 to a 2, the x value has increased by 1. From a 7 to a 9, the y value has increased by 2. That is a rate of change, or slope, of 2 over 1. One more to go. From 2 to 3, x has changed by 1. From 9 to 11, the y has changed by 2. If you make a rate out of that, the y changed by 2 when the x changed by 1. Notice you have the same rate of change from dot to dot to dot, so those dots must line up on a line. We're going to answer the question yes. Because they do line up on a straight line, we can find the slope, and we already did that. Our slope is 2 over 1, which reduces to just a 2. Question 27. Part A, find the slope of the line from this equation. Earlier we had questions where we found the slope from an equation, and we were able to do that if we changed the equation so it was in slope-intercept form, so that the letter y was alone. Let's do that. Subtract 3x from both sides. We get negative 3x when you move it to the other side. And here's the positive 8. Now divide by negative 4. Negative 3x divided by negative 4 looks like that. And then we have 8 divided by negative 4. Let's simplify this. Negative divided by negative makes positive 3/4 x. 8 divided by negative 4 makes negative 2. With this transformed version, we can find the slope. So for part A, the slope is 3/4. It's the number in front of x if the equation is in this format. Now let's do part B and get the y-intercept figured out. We practiced doing this the other day. The y-intercept is an ordered pair, and it's what's the value of y when 0 is the value of x. So let's take our equation that we just created and figure out what y equals when x is 0. So y equals 3/4, fill in 0 where the x is, and then minus 2 on the end. 3/4 times 0 is 0. 0 minus 2 is negative 2. We get y equals negative 2. By the way, do you notice that in the equation we created that the number in front of x was the slope, and the other number is the negative 2. The other number is the y-intercept. Okay, part C, we're going to make a graph of this. We know that the y-intercept is 0, negative 2. So on the y-axis, there's a dot at negative 2. The other thing we know about our line is the slope is 3/4, that you rise 3 and run 4. Let's put some more marks on that so that we have something to count to rise 3 and run 4. From our dot, 1, 2, 3. Now I'm going to run 4. 1, 2, 3, 4. There's another dot on the line. Question 31. Determine the value of A so that a line through these two ordered pairs would have the slope of 1/2. Let's use the slope formula. M equals y2 minus y1 over x2 minus x1. Remember that this is x1, this is y1, this one's x2, this one's y2. Let's make some substitutions. What are we going to fill in for m? Well, we're told m is 1/2, so put that where the m is. What do you fill in for y2? 3a. What do you fill in for y1? 5a. What do you fill in for x2? Negative 4. And what about x1? That's a 0. Let's simplify this up a little bit. This is the same as 1/2 equals And 3a minus 5a makes negative 2a. In the bottom, negative 4 minus 0 is negative 4. Let's simplify this up even a little more. Negative divided by negative is positive, and 2 over 4 reduces to 1/2. So we have 1/2 equals 1/2 times a. What's going to be the answer for a? A has to equal 1, because 1/2 times 1 equals 1/2. Now the review assignment. We're going back to page 83 where we were doing x-intercept and y-intercept. Our technique was to make a 2-column table and to choose 0 for x and figure out y, and then to choose 0 for y and figure out the x. Let's do that. We get 0 plus y equals negative 5. That just means y equals negative 5. That's the y-intercept. In the second row of the table, let's fill in 0 where the letter y is. So x plus 0 equals negative 5. That just means x equals negative 5. That's the x-intercept. Now number 4. First up, subtract the 5 from both sides. So we have x minus y equals negative 5. Now let's make our 2-column table. We're going to end up using a 0 for x and then later on a 0 for y. So 0 minus y equals negative 5. That means that y is equal to 5. That's our y-intercept. Okay, now the next row. Fill in 0 where the letter y is. X minus 0 just means x. So this is x equals negative 5. That's our x-intercept. If we were to draw a line on a graph, the line would touch the y-axis at 5, and it would touch the x-axis at negative 5. Okay, number 10. Let's add 5 to both sides, getting x equals 5. This equation is a special case. It has no letter y in it at all. If you were to graph this, it would be a vertical line that crosses the x-axis at 5. In fact, every dot on the vertical line would have an x-coordinate of 5. So one thing we can figure out is the x-intercept. X is equal to 5. That's what the equation tells us. But the y-intercept, we can't figure out. It's none. The graph never touches the y-axis. Number 25. This has decimals in it. I'm more comfortable with equations that don't have decimals. So I'm going to multiply everything by 10 to remove the decimals. When you multiply this decimal by 10, it moves one spot to the right, creating 1x. This one moves one spot to the right, creating 2y. And this decimal moves one spot to the right, creating 3. This equation is much nicer than the one we had before. Let's make a 2-column table and use the zeros to get our intercepts. A 0 for x and later a 0 for y. So we have 1 times 0 plus 2y is equal to 3. 1 times 0 is just 0. So this is really 2y equals 3. Let's divide both sides by 2. We get y equals 3/2. That is our y-intercept. Okay, now let's figure out the x-intercept. We're going to put a 0 in for y. So we have 1x plus 2 times 0 is equal to 3. 2 times 0 is just 0. 1x is just x. This really just says x equals 3. That's our x-intercept. Number 28. This equation has a fraction. I'm not really comfortable when there's fractions. So I'm going to multiply everything by 4 to get rid of the fraction. 3x times 4 is 12x. When you multiply this by 4, the denominator will cancel away, leaving negative 1y. When you multiply this by 4, you get 4. This looks a lot better. Let's make our table. We're going to use 0 for x. Later on, we'll use 0 for y. So 12 times 0 minus 1y, or that's just a y, equals 4. 12 times 0 is just 0. So this is really just negative y equals 4. So y has to be negative 4. That number is called the y-intercept. Now let's get the x-intercept. We're going to use 0 in place of y. 12x minus 1 times 0 is equal to 4. 1 times 0, that is just 0. So this really is 12x equals 4. Now divide by 12 on both sides. We get x equals 4 over 12, which reduces to 1/3. X equals 1/3 is called the x-intercept.